Welcome to S Chemistry. I'm your instructor Dr. Suhas Gauli and I will be teaching you BSc 5th semester Physical Chemistry course on spectroscopy. Here is the outline. First, I will introduce what is the electromagnetic radiation, followed by important characteristics of electromagnetic radiations, then regions of the spectrums. First, we will see what is meant by electromagnetic radiation. So radiant energy is emitted by fluctuation of electric charge and electric field, magnetic field. So that's how radiant energy is getting emitted. For example, like light, there are various forms of electromagnetic radiations such as ultraviolet, infrared, X-rays, radio waves, or etc. So ultraviolet we generally denoted by UV, capital UV, infrared denoted by capital IR, and X-rays are denoted by capital X and rays. So this is the general electromagnetic radiation diagram. So there are X and Y components are there in between. So you will have two different waves, that is in sine waves generally. So these blue lines corresponds to electric field component and the red lines uh, related to magnetic field component. So they are in the same phase but with phase 90-degree angle, so they are perpendicular to each other, so they propagate in z axis, z direction. So difference between two crust we consider as a wavelength. So their typical planes are electromagnetic waves. So now we will see some of the important characteristic of electromagnetic radiations. So first characteristic is, so these are produced by the oscillation of electric charge and magnetic field, so residing on the atom. So there are two types of oscillation. One is electric, due to electric charge, and another is due to magnetic field. So due to electric charge, magnetic field will generated. So that's why the two components are there. So the electric and magnetic components are mutually perpendicular to each other, and these are the coplanars. So magnetic field components are in the one plane, that is in y plane, and the magnetic the suppose electric field component in one plane, that is in y plane, and in x plane there will be magnetic field. So these are the two planes and they stays in that same plane. So second characteristic is these waves characterized by its wavelength, that is denoted by lambda, frequency, nu, or wave number or wave numbers. So third characteristic is, so the energy carried by an electromagnetic radiation is directly proportional to its frequency. So particular frequency has particular energy. So it is always fixed, uh, like that energy, if particular energy is there, and that if it has a behave as a wave, then it has a particular frequency. So the emission or absorption of radiation is quantized, and each quantum of radiation is called a photon. So wave can emit or absorb, so depending on the radiation, and so that whatever the absorption radiation take place, so that is quantized, so it will attain the particular energy levels. So that quantum of radiation we call it a photon. So fourth characteristic of electromagnetic radiation is electromagnetic radiation may be considered as a simple harmonic wave propagated from a source and traveling in a straight line, except when refracted or reflected. So any electromagnetic radiation you can take, that will always propagate in one direction. So until and unless is there between source and if there is a some disturbance becomes due to material, So either it will get refracted or reflected. So depending on the what are the materials we are using for the like to oppose the wave. So fifth characteristic is when the visible light or a group of electromagnetic radiation is passed through a prism. So it is split up into seven colors. So as we know, so the VBGR color is there: violet, indigo, brown, green, red, yellow. So the seven colors are there. So it will split after passing through prism. So these seven color are corresponds to a definite wavelength. So due to part difference, so it will split into the different wavelength, and this phenomena we call it a dispersion. So thus the group of electromagnetic radiation can be split up into various components for analysis. Now we will see what is meant by spectroscopy. So spectroscopy may be defined as the interaction between matter and electromagnetic radiations. So there is only whatever the interaction taking place between any matter, that can be solid, liquid or gas. So if that matter react with any electromagnetic radiation, whatever the electromagnetic radiation after interaction, whatever that is taking place, the study of that field we call it a spectroscopy. So there is another definition is there. So that it says that the study of spectroscopy deals with emission as well as absorption spectra. So an emission spectrum is produced by the emission of the radiant energy by an thermally or electrically and excited molecules. So the emission spectrum is produced due to the emission of radiation. So that can be emission take place from that can be emission can be take place due to thermally or electrically. So that is due to excitation of molecules. So what are the study we call it the spectroscopy. So there are two types of spectroscopy. One is absorption and one is emission. So now we will see what is meant by absorption spectroscopy. So in this absorption spectroscopy, we study the net absorption of radiation passing through a sample is monitored over range of frequency. So generally we will put different types of frequency, and we will monitor the what are the absorption rate, how absorption taking place into the molecules. So it will absorb particular energy and it will go to the particular energy state. That's how the absorption of radiation is working. So in emission spectroscopy, the electromagnetic radiation that arises from molecules undergoing a transition from higher energy state to lower energy state and is detected and its frequency analyzed. So in this spectroscopy, uh, some electromagnetic radiations that is arise from the molecules, that is due to they are going undergoing some transition that can be electronic, vibrational or anything. So it will always go from higher energy state to lower energy state. So due to this transition taking place, we are getting some different types of frequency. So that frequency, if you analyze, we call it emission spectroscopy. So now we will see some of the examples like absorption spectroscopy in details. So now for absorption spectroscopy, you need some absorption. So you will shine a particular photon. So if photon of a frequency nu falls on molecules in the ground state and its energy h nu exactly equal to the energy differences, that is delta E is equal to Em minus En between the two molecular energy levels, then the molecule undergoes a transition from lower energy levels to higher energy level. So from lower to higher it's going. So delta E that is taking place. So that is from the two molecular energy levels. So due to particular energy gap, frequency is falling on the molecule. So from ground state to higher energy state it will go. So this transition, molecule undergoes these transitions. So the lower energy level to higher energy level with the absorption of photon of energy h nu. So the spectrum thus obtained is called the absorption spectrum. So we will see in diagram in upcoming slides. Before that we will see what happens in emission spectrum. So here transition happens from lower energy to higher energy level. In emission spectrum you will get reverse. So here your molecules falls from excited state to the ground state with the emission of photon energy h nu. So here your molecules in excited state, it will get down to the ground state with the emission of particular photon. So that photon of energy that it will have h nu. So the spectrum thus obtained is called the emission spectrum. So these are the two types of the spectrums. And here in figure A and B, they have shown En, and that is initial, and this is a final, your Em, that is your higher energy. So these are the two different energy levels. So depending on if your molecule is in the ground state, it will absorb particular photon energy, and same energy it will go to the higher state after absorption of uh, absorption of photon into the molecules. So in other way, if your emission, this is the emission spectrum, emission energy levels. So here your energy excited molecules state, that is higher state, and after releasing some emission of photon energy, that is h nu, it will come to the ground state uh, here. So these are the two types of spectrum. So from this you will get the absorption spectrum, and from this you will get the emission spectrum. Now we will see what are the regions of the spectrum. So the arrangement of all types of electromagnetic radiation in order of their increasing wavelength or decreasing frequency is known as a complete electromagnetic spectrum. So if your like electromagnetic radiation has particular energy, so that energy can be measured into electron volt, or if it's their frequency is there, then we will measure in terms of nanometer or micrometer. So you have to place like in terms of increasing order, increasing wavelength or decreasing frequency. So this order we generally follow, or so this for order we call it complete electromagnetic spectrum. So here is the given picture in figure. They mention the depending on the energy of the frequency, energy of the electromagnetic radiation, they have arranged in such a way that, so here this is the frequency. So from in terms of frequency, this is the lower region and this is the higher region. So as left right hand side, it's a lower frequency, means lower energy. So lower energy is responsible for electron, this nuclear magnetic resonance. So the wavelength is generally in very low. So that is 1 meter to 5 meter. So in this range, only nuclear spin orientation is happening. So from another way, second is the radio wave frequency. So this is also generally from some 1 centimeter to around 10 meter. So this region is we call it radio frequency. So this is we use for the radio signaling. After that, microwave region is there. So microwave uh, also little bit lower than the infrared, but higher than the radio wave energy. So after that, infrared is there. So this is far from uh, red light. visible light than this infrared, so it has a lower energy compared to red light. So after that, vibrational infrared is there, so that is the typical range of wavelength. Is a 2.5 micrometer to 15 micrometer. So after that, you will be having the visible range, then ultraviolet, then X-rays. So that's how the arrangement of frequencies are given here. So this is the electromagnetic spectrum. If all types of electromagnetic radiation in order of their increasing wavelengths. So first we will see the cosmic ray, that is carrying very high energy. Then the infrared, so the portion above the visible region called infrared, less energetic. Then visible spectrum from the violet to red through rainbow colors. While that below it is the ultraviolet regions. Then radio waves for the are least energetic compared to all. So for mnemonics, like to memorize this spectrum, I have given some mnemonics. So the sentence is: Roman man invented very unusual X-ray gun. So RMIVUX. So there are types of the first is radio waves, so that is used for TV and FM radio. So typical wavelength it's greater than zero point 0.1 meter. So that is corresponds to change of spin. That is nuclear spin. So after that some M. So M is stand for the microwave. So that is the typical we use for the cooking and satellite signaling. So typical wavelength range is a zero point 0.1 meter to 1 millimeter. So this waves is responsible to change the orientation of the atoms. So next is the eye, that is infrared. So this is typically used for the remote controls and toasters. So typical wavelength is 1 nanometer to 700 nanometer. So this is responsible for the configuration of the atoms. So next one is visible electromagnetic radiation. So this is to our sense our worlds, just to see with your naked eyes. So typical range is 700 nanometer to 400 nanometer. So this is responsible for the electron change in electron distribution. So here your next one is a UV, that is ultraviolet. So this is germicidal, just to kill the germs. That is the typical range of 400 nanometer to 1 nanometer. Next one is X-ray. So X-ray is used for to detect bone cracks. So bone are made up of calcium. So if breaks is there between two bones, then X-ray will fall into the breaks, and that's how it get detected in the detector. So the typical range of uh, X-ray wavelength is 1 meter to 10 to the power minus 3 nanometer. So that is also responsible for change in electronic distribution. The last is the gamma rays. So the use of these gamma rays is to treat cancer. So typical range of lambda is greater than 10 to the power minus 3 nanometer. So this electromagnetic radiation is responsible for the change in nuclear configuration. So here we come to the end of these slides. So thank you for listening, and see you in next lecture. Till then, happy learning.